my friend. He was too cool to talk about.
All right, right triangle trig.
She's over here getting.
Right triangle trig is a major review of geometry, but we were building upon it quite a bit. So the first thing I had to write down was this triangle right here, and we're talking about theta. This is all in relation to theta. That's what this symbol is inside the triangle. That's what the symbol is right here, where it says theta. That's how we talk about the different things. So in relation to theta, here, in relation to theta, this side is opposite, this side is adjacent. Adjacent means what?
Next to.
Means next to, right? Like I'm adjacent to Alex right now. I don't know why she over there. That's weird. Anyway, so theta is how we're going to start all this. It may not be theta, it may be an actual angle. It could be a side, but when we're talking about the relationship between the sides, we're always talking about in relation to theta. Another thing we're going to use today is Pythagorean theorem. So Pythagorean theorem, we're pretty familiar with a squared plus b squared equals c squared. Questions about any of this so far? Great.
Oh, no.
There are 6 trig functions. There are 3 that you are very, very familiar with. Sine, cosine, and tangent. So I have those written down. Those are the first 3. That's SOHCAHTOA, or Oscar had a full of hands of aces, or whatever the phrase is. There's a couple different ones. I'm sorry, what's the 4th one? That is cosecant, secant, and cotangent. The parts in green are how we abbreviate all 6. So SIN, even though it spells sin, we're still going to say that as sine. We're not going to say cosine. I'm not going to say tan. Everything else, we're not going to say six or sec or cot. We're going to say cosecant, secant, cotangent. Those are the abbreviations. Then underneath that, we have all of the relationships of the sides when we're talking about theta. I'm sure you're thinking right now, good night, do I have to download these? It's not free. Yes, you will. Yes. I don't know the saying for the other 3, but there might be one. How does it go? What is it?
SOHCAHTOA.
Joseph Cow?
Yeah. CHOSH.
Sister Baker.
There you go.
Well,
Okay, so the last one is BOT.
Yes, cotangent. Alright, so the first 3, SOHCAHTOA, pretty easy. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and then lastly, tangent doesn't deal with hypotenuse at all, so that's opposite over adjacent. Remember, this is all in relation to a given angle, in this case theta. Then cosecant, secant, and cotangent are very similar to the first 3. It's just 1 over those 3. So cosecant is paired with sine. That's 1 over sine. So literally all we're doing is flipping hypotenuse in the opposite. So instead of being opposite over hypotenuse, now it's hypotenuse over opposite. Same thing for cosine. It's 1 over cosine for secant. It's hypotenuse over adjacent. And lastly, cotangent, you're just flipping tan, flipping that tangent. So 1 over tangent is adjacent over opposite. Yes, sir. Right. And these are going to be used pretty much the rest of the year. So plenty of opportunity to memorize these. So no, what do you might get? Thanks for taking that.
We try to Oh. I did mine now.
It's done. How are you doing?
Yep. Alright, we're going to be finding sine of C, cosine of C, tangent of C, cosecant, secant, and cotangent of C. To do all of that, probably need to figure out what the side CE is. So how will I do that? Pythagorean theorem. So a squared plus b squared equals c squared. Does it matter which one I call a or b? It does. No, it does not. As long as I square them and add them, right? So I'm adding a squared and b squared together. So that's going to be 6 squared plus 3 squared. That's 45.
Where's 6?
My bad. So the square root of 45 is, what's that? 3 root 5?
Yeah.
How did I get 3 root 5? Square root of 45, right? If you break 45 down, that's 3 times 3 times 5. I got a pair of 3s, take one out, yada, yada, yada. Cool. All right. Sine of theta. That's opposite over hypotenuse. So we're talking about in relation to theta right here. So what side is opposite? Is it DE, CD, or CE?
E. No. D. D. C. D. E. D.
Is it this guy, DE,
Yeah.
CE, or CD?
No. D.
Which one is opposite from theta?
D.
DE.
Oh, D. E.
DE. All right. You all on the same page now?
Yep.
All right, I know you said it, but like no one else. All right, so that's going to be 3 over the hypotenuse, which is 3 root 5. Why not? Let's go one step. One step. Oh.
I had a feeling.
How did I get that?
D.
All right, cool. Yeah, 3's cancel out. Cool. All right, for cosine.
So it wouldn't be just like the square root.
Yeah, but you have 1 over. Yeah. All right, cosine. That's what over what? Adjacent over hypotenuse. So that's going to be 6 over.
3 over
Did the hypotenuse change? So that's 2 over root 5.
Excited.
And then lastly, tangent is what over what? Cool, but like what's the sides?
3 over 6.
Opposite over adjacent? So 3 over 6, which is? 1 over 2. 1/2.5, well done. Alright, cosecant now. That's the same thing as 1 over sine. So since I already found sine, can I just flip my sine one? Is that cool? So sine's here, so I'm just going to flip those. So instead of being 1 over square root of 5, it's going to be square root of 5 over 1. Do I have to write the over 1 thing?
Wait, what? I don't understand what you said there.
These two.
Wait, what?
These two right here.
Yeah.
Okay, they're related.
Yeah.
Cosecant is 1 over this.
This is already that.
So if I do 1 divided by 1 over root 5, that's just like flipping this fraction right here. So square root of 5 over 1, which is just square root of 5. All right. What about secant of C? Okay. Square root of 5 over 2. That is the hypotenuse over the adjacent. It's the 1 over cosine. And then lastly, cotangent.
2.
Adjacent over opposite, so 2 over 1.
Where are you getting the 2 from?
We did tangent, just flipping. So 6 over 3. 6 over 3 reduces down to 2 over 1. Got more.
Oh my god, no.
I got 3 left. Alright, A says if sine of S equals 1/5, find SR. So we're talking about sine of S, so we're talking about now, like if I had theta right there, that's 1/5. So sine is what again for my sides?
Oh, I got it.
Okay, what is it? Opposite over hypotenuse.
Yeah.
So in this case, which side? RT? So that is 1
Yeah, my turn.
over 5.
Oh,
Waiting. So
Good.
1 and 5. Cool. Now I'm trying to figure out what SR is. So, Pythagorean theorem, right? A squared plus B squared plus C squared. Yeah. So 25 equals
Equals what?
1 squared plus B squared.
Can you just put that on the page?
You could, but whatever. So I got 25 equals 1 plus B squared still. So B squared is going to be 24. So I'm going to take the square of both sides.
What? I'm just gonna do the calculator. Did we just use the calculator?
Now, because I actually want to get a radical. So can I break 24 up at all?
Yes. What does it say?
Clearly.
Well, your handwriting is weird. It's too
Yeah, 24 breaks up into 2 times 12. 12 breaks up into 2 times 6. 6 breaks up into 2 times 3. So I got a pair of 2's there. So my answer is 2 root 6. That's what SR is. Sure.
Wait a second.
Waiting a second.
How did? No. What was your thought process in getting the 2, 2, 2, 3?
Because 24, the prime factors of 24 are 2 times 2 times 2 times 3.
How did you know that?
Break 24 up. So what times what makes 24? Do B if you get this. Do B.
Oh! I get it.
How do we do it here? So what should we get the 2? Wait, that's what Ashley said.
Oh, is that what you were talking about?
Ashley was like, this is really hard this year. Or,
Yeah.
that's our secret.
Oh, okay. It was the simplest.
Cool.
So it was like during the
No, they don't.
It was actually really cute.
All right. So that they tell us tan of T.
You said do it ourselves.
How about that? Okay.
I mean, I was trying to find all that.
All right. So we got tan of T. So that means that it's down here, right?
Why?
This T. T's right there. So 2/3 is where does the 2? Where does 2/3 go? Where does it go? Opposite over adjacent. Cool. Finding ST. So once again, I'm doing the Pythagorean theorem here. So 2 squared plus 3 squared equals C squared. That's 4 plus 9. So my answer is score 13. That's it. Questions?
Yeah.
What you got? Okay. Sir. Where did I never get the T or the theta? Since it said tangent of T, we're talking about T over here. So the tangent relationship is opposite over adjacent. So for T, for the theta to be here, that means 2 and 3 go there. If it was here, opposite here, that all right, cosecant, almost done. Almost done. Cosecant of theta is 5 over 1. Find tangent of theta. So, what is cosecant again? Okay. Alright, what's the trig functions associated with that? 1 over sine, right? So sine's opposite over hypotenuse, so this is going to be
90?
hypotenuse over opposite.
Yeah.
We okay with that? Alright, so if they say that cosecant is 5 of theta, is 5 over 1, that means that the hypotenuse would be 5, and the opposite would be 1. Is everyone okay with the placement of that? Yes? No?
Maybe so. It's the same thing as the
Alright, well, cosecant is the same thing as sine, or 1 over sine. Okay, if I want to find tangent of theta, do I have enough information to do that right now? I need the adjacent one, right?
Yeah. I don't understand why you put the data there.
This is given in the problem.
Oh,
Good question. Okay. Pythagorean theorem is probably necessary. So a squared plus b squared is c squared. I'm still going to be doing 25 minus 1 is going to give me my b or my a. So 24. We already found that. It's 2 squared root of 6. I literally have about 20 more seconds. Can we stop talking? Maybe?
maybe.
Cool. Thanks. So lastly, we're finding tangent of theta. Tangent is opposite over adjacent. So tan of theta is going to be opposite over adjacent. So my answer is going to be 1 over 2 root 6.